Nice. That looks great. I'm excited to read it when I'm done here. Okay, linear equations, linear functions. What's linear mean in your own words? You can write it up there. Linear equations. There's a hint.
An equation with lines.
Good. Straight lines. And there's a lot of really neat patterns that are found in linear equations. And so you get to start playing around with that and using different forms of linear equations. But here's what I want you guys to keep in mind. We're going to start using some different forms of linear equations. It's all based on the patterns that exist. Okay, so it's not just made up. It is based in the patterns. Okay, so let's see here. We have two linear equations here. Let's focus on the blue one first. And there's some vocabulary words that you were introduced to in Unit 4. What is a y-intercept? A y-intercept. Oh, that wasn't nice. There we go. Where can I write here? So your y-intercept is where man, this is being so mean to me. Okay, so your y-intercept is where your graph crosses the y-axis. Here's your y-axis. So where does our blue cross the y-axis? So Katie marked it right here. Good. It's up how many? 1, 2, 3, 4, 5. It is up 5. We want to write that as a coordinate pair. The coordinate pair for that y-intercept is 0, comma.
I couldn't hear you for a second.
Okay. Can you hear me now, guys? It said my internet was crabby.
Yeah, I can hear you now.
We can hear you now, but we couldn't hear you a second ago.
Okay, sorry about that. Your y-intercept needs to be written as a coordinate pair. Or sometimes people will say the y-intercept is 5. That is code for you that it is 0 side to side and up 5. Okay, so our y-intercept, you want to get in the habit of writing that as a coordinate pair. So our blue y-intercept is 0, 5. X-intercept, same idea. It's where, so we're on our blue line here. It's where our graph crosses the x-axis. All right, so go ahead and write in the coordinate pair here for this x-intercept. Good. Write it as a coordinate pair, x, y. Nice. 1, 2, 3, 4. Good. Also 5. Okay. So 5, 0. Nice job, Malachi, Katie, and Kaden. All of you guys work together on that one. Question. How many x-intercepts can a linear equation have?
Two.
Okay, on your own paper, I want you to draw a linear equation that has 2 x-intercepts. So let's look at this blue one for a second. It crosses our x-axis once. once here. In order for it to come back and hit our x-axis again, wouldn't our blue line have to bend and come back up? And it's not going to bend and come back up because it's a straight line. It's going to keep
Oh,
going.
wait. I
Okay.
thought it was the y and the x for some reason.
Good, yeah. So most linear equations are just going to have one x-intercept, and most are just going to have one y-intercept. Okay, most.
What if
Go ahead.
it's just a line? What if it's just a constant line against the x-axis?
Good question. So let's draw that real quick. So let's say you had something like, and this is the only case where it is different. So there's our XY axis. I don't know why it won't let me change my color. Let's say you had a line, it still won't let me change it. Let's say you had, okay, let's just pretend that you have a line that is right here along your x-axis. How many x-intercepts do you have there?
All of them?
All of them, an infinite amount, in fact, because you're going to notice that your line keeps going in both directions, to the right and to the left. Yep. But notice it still only has how many y-intercepts? It's only crossing that y-axis one time still. Good. Good job, you guys. Okay, let's go up here, find our slope of our line. So slope is our steepness. And who remembers, our slope is made up of, it's a fraction value. It's always a ratio. It is the rise over the rise value.
Run.
Good. The rise over the run. And in order to find your slope, you need to know 2 points on your line. 2 points on your line. So let's look at this blue again. We can pick any two coordinate pairs to find our rise and our run. Katie earlier found this coordinate pair and this coordinate pair. Goes perfectly through those crosshairs. So let's find the rise through those 2 points. How far apart are they up and down? I like how you drew that in, Katie. They are 2 units apart up and down, and they are 2 units apart side to side. Oh, I love that, Malachi. Good. And notice when we're going from right to left, we are decreasing. So that overall slope is going to be negative. So it's down 2 over 2 in this case. Down 2 over 2. What is negative 2 divided by 2 equal to? We can simplify that. Negative 1. Boom. All right, so our slope for that function, or for that, yeah, that function is negative 1. All right, let's find our domain and our range here. For that blue line, the graph did not include the arrows. I'm going to put them in. We have arrows on both sides, continuing on in both directions forever and ever more. So what is our domain, our possible x values here? The lowest x value, it's going to go all the way to the left. It's going to go to negative infinity. Our highest x value, it's going to go all the way to the right. It's going to go to positive infinity. Do you remember what we call it when it includes all the x values from positive infinity to negative infinity?
Infinite.
Okay, infinite. Also, we can say all real numbers.
Numbers.
Yes, good. All real numbers. Real numbers means your whole numbers plus all the fractions and the decimals in between. Covers all the possible x values. What about your range?
All
For
real
your-
numbers.
You got it. Also all real numbers, because it's going to go from negative infinity to positive infinity. Good, you guys. Okay, I'm gonna let you go at it here and you guys now fill in all this information for the red line. I'm gonna delete the things that I can here. It's not letting me delete some of my handwriting. I am sorry. Okay. Go ahead now and put in, you can write all this up as best you can. Go ahead and fill in the information for the red line. What is your y-intercept, x-intercept, slope, and domain and range? Good. If you haven't been able to look at one of them, go ahead and do it and see if you agree with the answers that are already written in there. I'm seeing lots of agreements in the work being shown. And I love the notation I see. I see the y-intercept written as a coordinate pair. And I agree, 0, 2. Go ahead.
I forgot to do on the y-intercept instead of where the two lines cross. So I think I did that wrong.
Okay. Yeah, so look for the y-intercept for the red line where it crosses the y-axis. And it looks like Malachi wrote in 0, 2.
I got I'm so confused now because I just did the slope, 3 divided by 6. And when I did that, I got 0.5.
Right. So we want to leave slope as either a whole number or a fraction. So we want to stay away from decimals for slope. So what fraction is equal to 0.5? Good.
I changed it to 3/4 because I changed it to the y-intercept instead of where the two lines cross.
Okay, so to find your slope, you want to use 2 coordinate pairs on your line. This upper point that you've chosen is not a point on the line.
Oh yeah.
Good. So use
Wait
that.
a second.
You
Oh
can
yeah, I
use
see
that.
what I did wrong.
Okay, good, good, good. So I agree with 1/2. Caden. Good. Up 1/2, up 1/2. Or up 3/6, up 3/6. And the domain and range are all real numbers. You guys got it. Good. Okay. There's a summative assessment just like this. Okay. You could probably go in and do it right now. Okay. I will stay in for a couple minutes if anybody has questions on anything that you want to talk about. But otherwise, we are done for the day going over new stuff. Okay. Good job with all your participation today.